Recording. Hello, I'm just going to show you the difference between an ellipse and a hyperbola. So first of all, I made this. I'm very proud of this Desmos creation that I made. So I'm just going to get that out of the way. I made it and I'm just so proud of it. I hope that you guys like it. I hope you find it interesting. And if you don't, at least you can know I made it. Okay, so this is just our basic circle right now. I can move it wherever I want. The center would change. Of course, I can move the center to whatever point I want. Let's just keep it at the middle. I can stretch it. Let's just say I had an ellipse and I wanted to stretch it, and let's just make it this, okay? So this is our ellipse from yesterday. One second, there's some crazy noise. Can you turn that down? My son was playing with a very noisy train. Okay, so let's just say I had an ellipse. That's what we had yesterday. If I was to stretch this a whole bunch, that would be what we'd call a eccentric ellipse. It has a big eccentricity. If I was to squish this down to nothing and kind of invert it, so pull it inside itself, if that makes sense, what I end up getting is something that looks like this. So instead of being a oval, it actually kind of comes into itself and explodes at the other end and goes off to infinity. It goes on forever in both directions. And if I was to do that in the x direction, that's what it looks like. If I was to do it in the y direction, that's what it looks like. So you can see that the ellipse and the hyperbola are directly related. You know, everything about the ellipse almost transfers directly to the hyperbola. Look, I can even put in the vertices. I wonder if I can put this on now. Yeah, even the vertices, I don't know, what error? What do you mean error? The vertices here I can put on. For example, yesterday we found this would be what we'd call the vertex. This would be another vertex. On top here, this would be the co-vertices. They still exist. They are still, let me take off, let me get it less complicated. They are still part of what we're going to do today. We're going to solve them in the exact same way. We're still going to get A, we're still going to get B. So in this case, look, you remember yesterday what A and B was? This would be A, that distance is A. This distance here is B. This distance is B. We have A and B just like before. The difference today is we're going to do something called well, we're just going to draw a box. We're going to go up from these, up like this, because we need to be able to sketch these things. Use A and B to build a box, and then we're going to make a line that goes through the box. So look, like this. And these are our, what we call our asymptotes. These are the lines that the hyperbola will try to touch, but will never meet, okay? They're lines that the hyperbola can go very, very, very close to, but can never touch it, okay? And so there's lots of terminology to bring up here, but the main idea is that it's almost the same as the ellipse. So if you remember what we did yesterday, 4 out of 5 pieces of that will be the same within a few changes. Okay, what were the 5 pieces? Center, vertices or vertexes, co-vertices, foci. The last one was eccentricity. Today it's not eccentricity, it's the asymptotes, it's the lines, those X lines. But everything else is basically the same. By the way, if I show you this asymptote, let me show you what I mean when I say it'll never touch. Look at this. If I follow along one of these axes, I go and follow it down. I'm like, hey, sir, it does touch. It does touch, sir. It's touching right now. Well, if I zoom in closer, they actually never touch. They'll never touch. So that's what the asymptote means. It's a line that it tries to get close to but never touches. So you might be like, okay, all right. What does this have to do with math? What does this have to do with what we're doing today? So let me try to get through this as quickly as we can so we can start doing the examples and you can feel better. I just finished a class with my other section and there were very little issues. They found it okay by the end, and I'm sure you will too. So the difference today. We have two things today called the transverse and the conjugate axis. The transverse is like the major axis, but not the same. I'll get to that in a second. The conjugate axis is like the minor axis, but not the same. And by that, I'll try to make it clear after. It doesn't, the biggest difference is that A is no longer the biggest number. So in ellipses, A was always the biggest. For hyperbolas, A always comes first. And by that, let me just jump ahead for a second. You'll notice here that A is always just the first number instead of the biggest number. So I'll come back to that in a second. There's other things that are very similar. A is still the distance from the center to the vertex. That didn't change. B is still the distance from the center to the co-vertex. That didn't change. And finally, C is still the distance from center to focus. That didn't change. The only thing that did change is, notice this, it's now positive. So instead of being negative, it's positive, but you have the formula sheet, you can use it. And that's the big difference, okay? Let's keep going. And you'll see once we do the examples, these are not that bad. So when you have these hyperbolas, notice the formulas here. I'm just going to erase this and show, I'll just put a little circle around here. Notice this, big picture. How to know which form gives you which shape. Listen carefully. If the x term comes first, if the x term comes first, or you could call it the x squared. If the x squared comes first, the way I like to think about it, because I like visuals, it looks, the shape will look like an x. What do I mean by that? I mean, it looks like an x, more or less. I mean, that's kind of an x. I mean, some students write x's like that. You know, it's an x. So if the x comes first, you know that right away. And what does that tell you? It tells you that the transverse axis is going to be in that direction, in the x direction, okay? That's your first piece of information. Let's go over to the other side. If you have y first, what do you think that means? If you have y squared first, again, Tom did this in his videos. I hope you're watching them because there's a ton of examples that I'm going to skip today. It looks like a y. I don't know, maybe it doesn't look like a y. What I mean by that is it kind of looks like this. You can imagine it's like part of a y. Not really. So it just looks like a sad face and a smiley face on top of each other. But the important thing is you know what that means. It means that that's the shape you're going to get if y comes first. Okay? The foci are still there. They'll be inside the curves like this, just so you know. And the transverse axis, which is like our major axis from yesterday, is going to be up and down in this case. So that's the one we add A to. So I know there's a lot to keep in your head, but most of these problems, at least half, maybe 75%, is the exact same as ellipses. Okay, so I think that's everything. If I've missed something along the way, I'll cover it as we go, okay? So this is a super important note. A squared is always the first denominator, but not necessarily the biggest. Ellipses. A squared is the biggest. Hyperbolas. A squared is first. That's the difference. Final thing before we actually do the examples. The asymptotes are these guys. The asymptotes are the lines that help us draw our hyperbola, which is our double curve. The equation for the asymptotes are clearly given here. But really, we don't look, everything's the same. The only thing that changes is this. And we'll see that it's actually a version of rise over run. How do I know that? Or what am I talking about? You'll see soon. But for the asymptote, you essentially find slope, and it's rise over run, and it's going to be your y-related term divided by your x-related term. And that's either going to be b over a or a over b. Whichever one is under the y, that's going to be going on top of this, and whatever goes on bottom. But we'll get to that, okay? We'll get to that. Let's start an example so that you don't fall asleep. Oh, by the way, if this ever comes up, this equation, it just means that we can have things that look like this. It can be some constant over x, or it can be some constant over y. Sometimes we see things like that. It's not going to be a big deal, but we actually saw it in the last unit, if you remember. But let's do an example, like I said. So this one was already done, I think. I think Tom did that one. Not going to do that one. Or will I? Let me see. All right, I'm just looking at some reference notes here. Yeah, I'm not going to do that one. I want to do the practice one. Okay. I want to start with a good difficulty one, the one that's not too easy. And let me just remind you before we start. You can take a picture of this or a screenshot or whatever you need to do. The 5 things we're looking for: center, vertices, co-vertices, foci, and asymptotes. And finally, what does each thing mean? Well, the center is the center. The vertices are the transverse axis related to A. Notice it says first, it's the positive one, and it gives us A. The next one is second and negative. We'll see how all these things connect in a second. Okay, so that's my spiel. Allow me to start and give you the full picture. Okay, let me talk you through this. It's going to get easier and easier. First things first. Which one's first here, x or y? Start easy. Which one's positive or which one comes first? They mean the same thing.
X.
X. Okay, so if x is first, it's going to look like this. We already know that. Before I start, it's going to look like that because that's how those things work if x comes first. It also means that our transverse axis is going to be there. So that's what's going to be our vertex and our foci. That's where they're going to be. So the foci is going to be on this axis and our vertex is going to be on this axis. And we're going to have a center in the middle. It tells us a ton of information before we even start. Okay, so let's go ahead. I'm going to write out the things that I need to know. First of all, what's the center? If you were alive yesterday, you must be able to remember this. The center, same thing as before. -6, -10. I hope that's not complicated. It certainly doesn't, it shouldn't seem complicated. Let's now write out our A, B, and C. A squared. Now, okay, this is our first difference here. What is our A squared? Let's see who's been paying attention.
9.
My man, 9. That's because it comes first for hyperbolas. Excellent. If this was yesterday, it would be 16, yeah? So today it's 9. It came first. Okay, so 9, square root of that is 3. I'm going to go ahead and get B and C after, just like I normally do. So B squared must be our 16, just like yesterday. B must be our, B must be 4, square root. I'll go ahead and get C. C squared is what? Well, yesterday it was A squared minus B squared. Today it's going to be A squared. Why is this popping up? Get out of here. Sorry. A squared plus B squared. We already have A and B squared. They're right here. They're right here. They're already there. You don't need to do anything extra. C squared must then be 9 plus 16. Well, this is a nice one. That means that C squared is 25, so C must be 5. Okay, are we all right with that so far? Nothing too crazy. Pretty much more or less the same as the ellipse with a few tiny differences. I'm going to sketch this. You're welcome, Abdo. And it's a little bit tricky, this one. because it's not asking for a sketch, but I want to sketch it so you know what I'm doing here. So first of all, I'm going to sketch the center. -6, 1, 2, 3, 4, 5, 6, -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to do my best to put the center here. It's about there. Okay, to me that looks right. That's my center. Now, I need my vertices. And there are a million questions you need to roll through your head to make sure you know where that goes. But I'll just ask you, are the vertices going to be left and right by A or up and down by A?
Left and right by A.
Yes. So I'll go right 3, because I'm going by A here. I'll go 1, 2, 3 to the right. That's close enough. I kind of messed that up.
-3.
3 to the left. 1, 2, 3. Again, this is tricky without graph paper, but I'm doing my best. Those are my vertices. I'm going to write down what they are now. Let's see, that would be our center, so our x value. So center -3, that's -9 and -10. And then our
-3 and 10.
-3 and -10. Yeah. So notice that the only thing that changed here is this one. Just in case you're not sure why, remember we're moving in the x direction, so it changes the x value. Let's do B. We need to go up and down by 4 from the center. So up by 4, 1, 2, 3, 4 is about here. So I can write that down first.
-6 and 6.
-6 and
-6.
-6, yeah. The next one is a little bit trickier because I kind of ran out of space, but I'll do my best. Got to go down for 1, 2, 3, 4. And then you're saying -6 and -14, Hamza? Yeah. -6, -14. And I'm going to write that on. Okay, I've got that. So once again, it's the y values that change there because of the way it works. Just as a recap, I knew when I first looked at this problem that it's the x first case. That means that the parabola or the hyperbola is going to look like this. And it means that that's the x-axis. Everything has to do with the x-axis. Sorry, my wife's calling me. What? Just try the rest. I got to go downstairs for a second. Sorry, it's a slight emergency with my child. Sorry about that. Turns out it wasn't an emergency with my child. It was an emergency. Well, my wife said it was an emergency. It was actually just a big pregnant cat came in our living room and wouldn't leave. And my kid wouldn't stop playing with it. Okay, so anyway, we did our co-vertices. I'm going to do something new now, which is at this step, I'm going to draw a little box, which I don't know if I told you about that yet. I'm going to zoom in on this diagram. I'm going to use our B and C. Remember, this is A really. And this is B, just so you don't forget. Draw a box around them. This might seem kind of random at the moment, but it's very important. Draw a nice box. Use a ruler. I didn't do a very good job. Use a ruler. Draw it. And then you take the corners and you connect them. Those are going to be what we call our asymptotes, which I mentioned before. And please try to use a ruler. You're going to be expected to make at least a decent sketch. And this is what it's going to look like. If you don't have graph paper by now, I've told you to get it. You might be struggling a little bit, especially if you don't have any notes printed, but Do your best. Foci is -11, -10, -1, and -10. Good job, Hansa. That's right. So we draw this. Now the sketch is going to be important because later we need to graph it anyway. So I'm just making it part of the question. We can draw our hyperbola now because I know it looks like an X. And what it needs to do, it needs to come along the asymptote without touching, go through the vertex, and then go back out to the asymptote. So it looks like this. Down along the asymptote, touches the vertex, and comes back out. It never touches the asymptote. Do not touch the asymptote. If you touch it, you lose a mark right away. They are not allowed to touch. That's part of the definition. It is the definition of the asymptote. It cannot touch it. You're not allowed. So as long as you don't do that, you should be okay. That's pretty ugly. Let me try that again. Okay. So what you'll notice, they are kind of like parabolas, but they're not quite as smooth. They almost look a little bit more like a point. Sometimes they're almost as if they're trying to become a triangle. And there's a good reason for that, but we won't get into it in this course. So that's our sketch. We can see that we have pretty much everything we need. We got the center and the vertices and the co-vertices. The only thing we need now is what Hamza gave me, which is the foci. So the foci, I go from the center over by 5. So 1, 2, 3, 4, 5, that would be -1. And left by 5, 1, 2, 3, 4, 5. It's about there. That's a little bit tricky to get, but you know, just be careful. Left, the center, -6 minus 5. That's -11. And -6 plus 5, -1. And I'm almost done. Asymptote is y plus 10 plus or minus 4 over 3x plus 6. You're killing it, Hamza. How do you get all this stuff? Do you get it just from my explanations? Do you do extra practice? Are you cheating somehow? Are you watching the videos? What is it? What's your secret?
Of course he's cheating.
He's found one of many calculators online that give the final answer, maybe. Or maybe he's just smart. Possible. Very possible.
No way.
I don't know. Give him the chance. Yeah, salty. Abdo's a little salty today. It's okay. We'll figure it out together. So, one thing I didn't get was the asymptotes. And let me re-explain how that works. I need to. I'm just going to make some space. Okay, the asymptotes. Listen very carefully. I mean, you should always listen carefully, but listen more carefully. The basic equation is always the same. I'll write out what the basic equation is. It's y minus k, x minus h, plus or minus something over something. You put the term with the a on top, the term with the b on bottom. Notice I can steal, you know, this x minus h is already there. And this y minus k is also already there. So we don't need to worry about that. We just steal it. So I'll do that. Y minus k, so y plus 10 equals x plus 6. Once again, I can take that directly, yeah? But the asymptotes are plus or minus something. And you just very carefully look over here. I'll make it as clear as I can. I'll make it super obvious. That number on bottom, well, that wasn't very obvious. This number, what is it? 16, that's under the y, that's the one that goes on top. Rise is the y-related value. In this case, the a. And then on bottom is the x. Rise over run. Or in other words, look at this. The asymptote should be up by b and over by a is the idea. So in any case, I'll write it down and explain it again after. It's 4 over 3. That 4 is A. This is B. The reason I chose A is because it's related to the Y. The reason I chose B is because it's related to the B. Okay? It's rise over run. And I do genuinely believe that Hamza is actually a clever guy. I don't think you were cheating. I think you're just doing the work. I had you for physics before. I know that you do hard work. So I'm going to give you props for that. And if you're cheating, then you're a horrible person. And I hope you get 0. Okay. Just get that out of the way. Okay. That's it. I got the center. I got the vertices. I got the co-vertices. I got the foci. I got the asymptotes. I'm going to graph it on Desmos so you can see that we've actually done what I'm saying we're doing. We've actually given the correct points here. So I'll go one step further. I'll graph it. You can always do this yourself, although some students don't like to do it because it seems like a lot of work. Okay, it's gonna have this form. By the way, before I finish, before I even graph this, what is the difference between an ellipse and a hyperbola? Like, what's the difference in the equation? What's the difference? What's the difference between what we did yesterday and what we did today? What's the single difference? There was one difference in the equation.
I think the slope derives over 1.
That's another step at the end, but I mean the original equation, like if you look at this original equation here, what is the difference? And I'm not talking about eccentricity either. I'm looking at the original equation. What's the only difference?
A and B?
No, when you read it, you don't notice that difference. It looks exactly the same. Like what A and B does, of course, is different. The only difference is actually this minus. Ellipses never have a minus in the center. Ellipses are always plus in that center. The x squared term is positive, the y squared term is positive. For hyperbola, there's always a minus in the center. One term is positive, one term is negative. So there will eventually be questions saying, how do you know which one's which? Well, the ellipse looks kind of like this. There's a plus in the middle. The hyperbola, even it doesn't matter if x or y comes first, there's a minus in the middle, okay? So just something to keep in mind. Just one second. In a busy house today. So let me finish graphing this so you can see that I'm not lying to you. I am doing what I'm saying I'm trying to do. X plus 6. You know, if you don't care about this, take a break for a minute or two, but this is pretty cool as far as I'm concerned. But I find stuff cool all the time. So square this, put this over 16, and that's equal to 1. So look, so far, so good. That is very close to my sketch. I mean, I did it freehand, but it's basically the same. Let me put in my vertices, -9, -10. -3, -10. Those are my vertices right there on the graph. Perfect. -6, -6, co-vertices. -6, -14, co-vertex. Foci, -11, -10. Good, it's inside one of the curves. That makes sense. -1, -10. It's inside the other curve. That makes sense. Perfect. And now my asymptotes. Of course, you don't need to do all this. I'm doing it so you see what I'm doing. I'm going to graph my asymptote. Y plus 10 equals positive 4 over 3, x plus 6. Ooh. And y plus 10 equals negative 4 over 3, x plus 6. Okay. Ta-da! Let me clean this up just a tiny bit. These are my asymptotes. So I have a red curve. That's my hyperbola that I made, that I've been trying to do here. And then if you look at the asymptotes, look, that's definitely correct. We definitely got the right equation. And if we follow one of the lines, it looks like it touches, but really it never does. Okay? So we've successfully drawn what we thought we drew. And look, the last thing I'll say, and I'll fix this now. What did I say the difference between a hyperbola and an ellipse was? The very single difference? The only difference?
The minus?
Yeah, so what will happen if I turn this to a minus? It will go, bam, ellipse. It will turn into an ellipse. Look, I'll just put it down here, change it to a plus, boom. Now it's an ellipse, and I have my co-vertices, my vertices, They're directly related to each other. The only difference is the plus and the minus. Hyperbola, circle. Hyperbola, ellipse. Okay? You don't need to do all this. I'm just showing it to you so you see the connection. If you don't know the connection, it's not the end of the world, but I'm trying to help you make the connections. Okay? So that's it for now. That's my Desmos spiel for now. C is very similar to the last one. I'm actually going to skip it for now, I think, because there's other ones that I'd rather do. Actually, maybe C. Let me take a look at my notes and see if C is okay. Yeah, no, let's move on to do the next page. And I know Tom did some of these. I don't know if you saw the videos or not. Nice wallpaper. Oh yeah, you like that? It's me, Mario. Okay, so I've got some graph paper here. We're like twins. If you have this printed, it'll help a lot. I'm actually not going to say this is homework. I'm going to do this with you. It's another of the exact same type. I'm just going to do it a little bit faster this time so you can see it again. I love Mario. I've loved it since I was 3 when I first played it. So let's do this. Sketch the hyperbola. First things first, what is it going to look like? Which term comes first, x or y? I mean, it's a pretty easy question. It's clearly x comes first. That tells us a ton of information. Oh, Kevin. X first. If x comes first, it means it looks like an x. If x was not first, it wouldn't look like an x. We know now that the transverse axis is in this direction, just like the last problem. And we know the vertex will be on that direction too, and the center will be in the center, all that stuff. It also tells us that A is there. It's 4, okay? So let's go through the motions. First things first, I'm going to say what the center is. The center in this case is -1, -1, just like last time, yesterday. I'm going to go ahead and show you, I can get the asymptote right away. I'll do it now because it's super fast, okay? Asymptote, I'll just write it here as a sketch. It's y plus 1. I stole it from here. And I'll steal this bit too, x plus 1. And I just need to do plus or minus something over something. What's the something and something? It's the square root of this and the square root of this. Why is it those two? Because it's the square root of the one under the y, the rise, the square root of the one under the b, or the x, the run. So that's 4 over 2. We'll see that will be our b, and we'll see this will be our a. So I just wanted to show you, you can do it right away. So let's do a, b, and c. What's a squared? It's the first one. It's not the biggest one, that's ellipses. It's the first one, so 4. That means a is 2. Moving on, let's do b squared. B squared must be 16. It's the second one, or the one that touches the negative. That's a 4. And c, what's c squared now? You remember the formula? A squared plus b squared, same as Pythagoras. So we have these two already. 4 plus 16. 4 plus 16. That's 20, so it's root 20, which is a little bit weird. So 2 root 5. If you want to know the decimal for that, that's fine. You can write it as a decimal. It'll be 4.47. Okay? Just in case you want to write it as a decimal, you're perfectly allowed to do that. There's no problem. Let's start sketching. The sketch is what it asks for after all. It says sketch it, but we also need all the pieces. Center -1 and 1. Right there. We know that it looks like this. I'm going to keep doing this. It looks like this. So the main transverse axis is this one. That's where the magic happens. That's where the vertices are, and it's where the foci will be. So we go left and right from the center. Left and right. So my vertices I can get from that. Left from the center, so -3, -1. Right from the center, 1 and -1. Notice that it's the x values that are changing because I'm moving left and right. Some students, that is very difficult for them to keep track of. So you gotta be thinking about this. You have to do the practice or it'll just get lost. It'll float out of your head and you'll never come back. What about the co-vertices? Up 4, down 4. 1, 2, 3, 4. Down 4, 1, 2, 3, 4. All right. So if this were an ellipse, I could draw it. It's not an ellipse, but it's the exact same steps. Co-vertices. Up 4 is 3, yes? So it would be -1. -1 up 4 is 3. -1, and then I reduce this by 4, so -5. If I make a mistake, please let me know because I might never catch it. I think that's pretty good so far. What do you guys think? Any mistakes anywhere that you need re-explained before I do the rest?
All clear.
Okay, good. Now, I have, thanks, Yasser. I have my transverse point with the A. I have my conjugate axis with the B, and I'm going to draw a box. So the box looks like this. Now, this is an easier box to make because I've got lines now. Hopefully you have it printed, and if not, you have Graph Digger. Once you have that box, go through the corners. Make the X. So use a ruler, definitely. If you don't have a ruler, use the side of your phone or something. I don't care. Just do your best. But make it as clean as you can. And it should look like this. Now, of course, I've got colors. So I've got an advantage, but pens don't cost that much. You can buy some if you want to, or colored pencils. 63 degrees. What a fancy tool, gives me the degrees and everything. Okay. That doesn't look quite right. Let's not get caught up in the details, though. Okay. That's my, what are these called again? Those fancy lines. Asymptotes. They are the lines that will tell us how to draw our hyperbola. We go along them, but we never touch them. So let's do that. Let's go along that line. It should look like this. Come back down. Close enough. It's never going to be perfect, but I've done a good enough job on that one. I'll try the other side. Go as close to the asymptote as you can without touching, and come back out. And again, not perfect, but that's about as good as I'm going to be able to do at 4:30. Okay, I got to redraw that. It's terrible. I don't think that's any better, but I feel better. I feel better about that. Okay, so what have we done? We made the center. I found A, B, and C. I just like to go in that order. Then vertices I got from my sketch. Co-vertices I got from the sketch. Then I drew the box, and now I can make my sketch. I'm mostly done. I still need to show what the foci are, and I still need to give the asymptotes. Even though it didn't ask for it, I'm just making you do it every time, just in case I ever ask for it, okay? So foci, you can see I knew what it was going to be right from the beginning. It's going to be in the X direction. So take the center, add and subtract C. So this would be the X value of the center, -1, plus 2√5. I'll give you the decimal answer for this after. And this is -1, that's the center, minus 2√5, and -1. So if you're not sure, I'm taking this X value and I'm adding. Yeah, I will, Zara. Just let me finish my thought here. So I'm just going to sketch this, and then I'll go back through your question, no problem. So -5.47 is 1, 2, 3, 4, 5. About there. 3.47, 1, 2, 3. About there. Does that look right? Something looks weird. 1, 2, 3, 4, 5. I feel like I have a mistake. Anyone see this take? Ah, yeah, this one. There we go. I'll do the asymptotes and then I'll answer your question. So asymptotes, we already did above. The asymptotes are y plus 1. I took that from the top. Equals, what's 4 over 2? Well, it's 2. So plus or minus 2, x plus 1. Okay, so while you're finishing up that, I'll answer your question, Zara. How do we get v and cv? So actually, let me make sure that no one else needs this, because I'll kind of rewind and I'll show you again. It's one nice feature of this. I'll do that, and then if you need me to show you the final answer again, I will. Okay, so just watch this. So I got the center, I worked out the asymptotes. I figured out A, B, and C respectively, yeah? And then I ended up graphing the center. So you'll notice I just have the center on my graph here. Isn't it cool? Isn't that like the coolest thing you've ever seen? You know, if you had OneNote and I shared this book with you, you would be able to do that with my solutions. And I can go back a year and go to my notes from a year ago and still see it. So right now, Zara, I have my center on the graph. I know that the transverse axis, the main axis, is in the x direction. So in order to get my vertices, I need to go left and right by a. So I take my x value for the center, I subtract a, and I add a, and those are my two main values. So you'll notice here, I went left and right by a, because a is 2. Then I wrote down, just based on my sketch, I wrote down what that is. -3 and -1. I can see that that's right there. And I can do 1 and -1, which I can also see is there. Is that okay so far for the vertex or the vertices? So if you got that, then the co-vertices are the same story. As long as you use A for the main axis, the co-vertices are the same story, but for the conjugate axis, the other axis. Just go up by 4, down by 4. Up by 4 and down by 4, and then I can just read that right off. Is that fine? Is that enough? And the same idea for the focus. Okay. So I'll just Dr. Strange this here and fast forward time. All right, and then I am at the end of the question. So that is fully everything that I could really ask you for if I'm asking to sketch the hyperbola. There's only 5 possible things, and they all have to do with A, B, and C, really. So if you understand what A, B, and C are, you should be able to get the rest. We'll do more examples, of course, but hopefully this is starting to make sense. So we've done 2 different types. Actually, we've only done 1 type. We've only done the X first type. We haven't done the Y first type, where we have the happy and smiley face, smiley and sad face on top of each other. So let's do that. The next example is a case where that is the case. So once again, Tom did this. Tom did this in his video. But because this has graph paper and because it's such an important topic, I don't mind going through it again. And I'm not stupid. I have analytics of every single view for the videos. I know they're not being watched by everyone, but they are being watched by some. So, you know, hopefully when it gets around to the test, if you haven't seen the videos, you're not too shocked by the fact that, yes, there could be questions from just the videos on the test. Just don't make me say I told you so. Okay, let's do this. First things first, let's check and see what type it is. I'm going to look at this and say, yeah, nice advice. I'm just being real, man. I can see that the Y is first. So if the Y is first, it's not going to look like an X. It's going, the transverse axis is going to be up and down. So that's the direction that it's going to be in. What I mean by transverse axis, I mean everything is going to happen on the Y axis now, because everything is like Y is the main thing here. So, you know, everything goes up and down that axis. And so I could put my center in the middle if I wanted to. You don't need to. Vertices are going to be there, focus is going to be there, And everything has to do with that, yeah? So let's start the process. Center, what's the center? Center is 2, -1. So I already have my h and k. What about a? A squared is not 16. That was for ellipses, you silly goose. A is the first one, 4. So a must be 2. So let's go ahead and sketch that already, just in case you want to do it bit by bit. So 2 and -1 is right here. I put that on the graph paper. 2 is my a. Be very careful that you don't lose track. This a is related to the y. You know, it's under the y, which means I need to go in the y direction when I am going from the center. So I need to go up by 2 and down by 2. Now I can write what my vertices are. So let's see, that would be 2 and 1, and that would be 2 and -3. It feels right. Is that right? I'm looking at my previous notes, and I feel like maybe that's not right. Oh! I make this mistake all the time. This is not my center. It's not my center! Why is it not the center? Well, it's not my center because this is H, and this is K. So I should have written H first and K second. So it's -1 and +2, because the Y value comes second always. So right away, if I had done that, every single coordinate would have been wrong. So you can see how this stuff can kind of go off the rails if you're not careful. So I wasn't careful, but by the power of technology, I can move this around. And you would have to erase it, but you know, I got the cool gadgets. Because I'm the teacher and I have 3 degrees. That's what you get when you work hard. So what are the vertices? -1 and 1, 2, 3, 4. This is -1 and 0. Okay, so hopefully you understand why. It's the same reasoning as I gave Zara before for the x, but because the main axis, the transverse axis, is to do with y, we have to add it to the y and subtract. So b squared is 16. Means b is 4. Just like the previous question, actually. Kind of nice. So I need to go left and right from the center by 4. 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. And once again, if this was an ellipse question, I could draw the ellipse. It's not an ellipse question, so don't draw the ellipse. I can draw the hyperbola, though. Let me write down what the co-vertices are. Co-vertices are what? Negative 1, 2, 3, 4, 5, 6. -6. -5. And 3 and 2. -5 and 2 and 3 and 2. I don't like to write this up on the graph here because I find that it makes the graph already, it makes it way too busy. Like there's too much going on. I'm going to draw the box. Box time, drawing a box. It's really good times. Okay, and now I'm going to connect the corners. 26, maybe? 26-degree box. Asymptotes. And let's go, should be 26 degrees the other way. Yeah, how fancy. And let's see. Should look something like this. Again, use a ruler. If I have a free hand, you know, asymptote that's all squirrely and weird, you don't get marks for that. It's just, there's no reason I should give marks for a really, really bad graph. So get a ruler. You all have a phone, you know, if you have to use the side of your phone. Something straight. Your arm, I don't know if that would work. I don't know. Be creative. So what else can I do? Oh, I can draw the hyperbola. What's the hyperbola going to look like? Well, I know ahead of time it's going to look like this and like this. It's going to not look like an X. It's going to look more like a Y, I guess. It looks like this. Whoa. Good enough. And woo. Good enough. Again, do not touch the asymptotes, please. No touching. No touching. Just looking. Okay? And now we should do our foci. Because we've drawn it, but we still need to put our focal points on this. So c squared is a squared plus b squared. We know what a squared and b squared are. It's 4 and 16. 4 and 16 is, oh, we did this last question. It's 2 root 5. Which is the same thing it was before, 4.47. Okay, so when you go to make the foci, you can use that. I'm going to go up and down by 4.47 from the center. So 1, 2, 3, 4.47 is about that. Down from the center, 1, 2, 3, 4, and about a half right there. That's my foci. I was going to say it looks like a sand timer. And the reason I didn't is because, if you had something like this, and whatever, you had this, I felt like you could kind of, that's kind of both, It kind of looks like this and it looks like this. So, who's to say? I thought it might confuse people if I gave that. So whatever helps you, whichever helps you remember is what matters to me. I don't really care how you remember it as long as you do. And as long as you don't use someone else's brain to remember it for you during the assignment or the test. Did I already tell you I gave 2 zeros? I hate giving zeros. Really, I hate it. But 'tis my job, and I'm under a lot of pressure to make sure that I enforce the rules. So, I got to do what I got to do. Anyway, foci. What's it going to be? I've only added to the y values of the center. So the x value of the center stays the same. And let's see, add. What's 2 plus 4.47? It should be 6.47. And then negative 1 stays the same. What's 2 minus 4.47? Is negative 2.47? Feels good. Okay. I think that's right. So let's put in the asymptotes and we'll be done with the question. I'd like you to give me what the asymptotes are. Can someone tell me what the asymptotes are? Someone just write it out. There's no squares because it's a line, yeah? 2 lines. What's it going to be? I moved my laptop, by the way, so now I can actually look at the answers. I don't need to look over here every time. Anybody? Are we running out of energy? Anyway. Euler. Okay, I'll give it to you. It's always the y minus stuff, x minus stuff, and then your plus and minus stuff, okay? So you have y minus 2, I steal that from the top. I have my x plus 1, I steal that from the top. I'll even highlight it for you. What a concept. Okay, I just stole that, and then all you need to do is put A or B on top and bottom. Which one's on top? It's the one related to y. Which one's related to y? This one. That's a squared, we need a, so 2. 2 on top. That's a, because it's related to y. On bottom, we put 4. Why do we put 4? Because that's b. Now, I need to simplify this. So maybe I'm going to erase the a and b and put 1 over 2. All right, that's the big idea. Is there anything I can, now you know, is there anything I can clarify for this? Now I've done 3 examples. They're all basically the same. I hope you can see that. I'm going to do more. I'm going to do examples until I pretty much fall asleep, like I said before. But anything I can clarify for this question? So I want to do, okay, good. I'm glad that it's clear to you, Kevin. Hopefully it's clear to the rest of you. I want to show you why it's rise over run like this. Like, how do we know how to get the asymptote? Well, the center of the asymptote should be clear because of this. So really, it's the slope that we're concerned about, right? Like the form of this is really y equals mx. I mean, the y is shifted, the x is shifted, but really what we care about is this m, which is a slope. How do we get it? Well, we just look at our graph. Look at this. Look at this. Okay, look. From the center going up, that distance is a. That is our rise. That's how much we've gone up. If we go over to where the asymptote is, that is b. That is our run. So the slope is always rise over run. So if the slope is rise over run, in this case, the rise was A and the run was B. And if we connect them, that's why we get the line with the slope that it has. It's why the asymptote has A over B for this case. So let me try to summarize it. If it's in Y first form, you use A over B. If it's X first form, you use B over A. But I don't like you to memorize things like that. I'm just writing it for you to remember and to think about. But really, if you understand it, you don't need to memorize as much. That's why I like math so much growing up. It just made sense to me because I didn't need to memorize. You just try to make sense of it and you'll be able to remember it a lot better than if you try to memorize something on page. But we all know you're busy. So if you need to memorize, go ahead and do it, whatever works for you. Okay, let's do a few more examples. I'm running out of steam as I normally do at this point. The rest here, 3, Tom did. Tom also did 4. 5 is a challenge question. You don't really need to worry about that. I wouldn't ask it on a test. Practice 2, I'll say the first one's for homework. I can do more of these. You know, I've already done one of each of these. Do you want me to do these 2 practice, or do you just want to look at the solutions later and try it yourself? Like, do you want me to do more examples like this? I'll do as many as you want me to do. We're not done. If I don't do more of these, I've got to do another type anyways, yeah. So maybe 1. Okay, so in that case, which one, an X type or a Y type? Because they're both basically the same. Do you find one or Y type? Okay, let's do a Y type. So this B is a Y type, and it's actually a really weird one. I'm not sure why they gave it. It doesn't graph nicely, is my point, but it doesn't matter because we can get the coordinates easily. So I'll do B, okay? And maybe I'll post the solutions for C later. I did it in the other class. Okay, so let's look at this. What's it going to look like? I can tell it's going to be Y type because X type is too mainstream. You guys crack me up. Okay, the first one is Y, so it's going to look like this. Oops, look like this. Or sand timer, or whatever helps you remember it. And then the A is going to be in this direction. That's our transverse axis. So everything that's special is going to be in this direction, up and down. Man, my surface is jumping around, I'm sorry. So the center, first things first. Center is going to be what? What's the center? Don't get it wrong. Don't jump to conclusions here. What's the center? Someone's awake. -2 and -8. Excellent. So that's our center. That's a weird looking 2. Let me fix that. -2 and -8. While it's on my mind, I'm going to write the asymptote up here. So the asymptote, just because we just talked about it, 5 plus 8 on the left. On the right, it is x plus 2. And the y one over the x one, so this is going to be root 36 over root 25 is 6 over 5, plus and minus. Just 1 second. Okay, so this is my asymptote. I'll come back and rewrite it later. What am I going to do? Big surprise. I'm going to get A's, I'm going to get B's, I'm going to get C's, and we're going to make some sketches, and we're all going to have a good time. Kevin, it's not -8 and -2. You're just standing over there. Over where? I don't know what you're talking about. Okay, so oh, I'm just over here like, oh God, this class. Okay, and I'm back. No, I have to open the door to let the cat in. So a squared, first one, 36, 6. B, you can do this, of course, on your own. You don't need to have me do it for you. You can try it yourself. B squared is the second one, 25. That means B is 5. C squared is a squared plus b squared, so 36 plus 25. When you work that out, it's going to be root 61. And if you want to do it as a decimal, you can say 7.81. It means the same thing. Same. I'm going to put those on my graph. And you'll see right away, it's a little bit of a weird graph. So -2, -8, down here. -2, 1, 2, 3, 4, 5, 6, 7, 8. There we go, -2, -8. That's going to be a problem. I can't go very far down from that, but I'll deal with that in a second. So A, wait, why A is not 25? Because A is always the first one when we deal with when we deal with hyperbolas. A is the one that comes under the positive one. So because Y came first, this is going to be our A. And if you need, if you want to be crystal clear on this, I will just jump back here for a second. You can write these down, save it in a formula sheet for yourself, whatever helps. Notice that the equation is there, and it will remind you for hyperbolas which one is A and B. And you'll see that because Y is first, it's actually A on bottom. If X was first, it would also be A on bottom. So A is always first, but you can check it with the equation too. Where was I? So I'm going to sketch this. I need to go up and down with A, yeah, in order to get my vertices. So I can go up by 6, no problem. 1, 2, 3, 4, 5, 6. I can go left and right by 5, no problem. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But I can't go down by 6. So this is a really annoying graph. I don't need to find that point though, because I can still make a box. Let me show you. I mean, I'll still write the point when I write the vertices, but I'll show you that we don't actually need it. We can do good enough. Why don't I need the bottom of this box? Well, because it goes from the corner to corner, yeah. So it'll go from corner to corner and make these asymptotes. But it's going to also go from the corner to center. So I really only need to go through the center. So I don't actually need a completed box. It's okay if I just go through the center. Okay. It's not the end of the world if it doesn't show on the graph. You just make do with what you have. And then I get this. All right. So good enough. It basically goes through the center. I know that this is going to look like it's called a catenary actually. It's like a hammock or a swing or something, and I can draw the parabola this way, or hyperbola, I should say. Whoa, my hand slipped. Almost touched that asymptote. But I feel pretty good about that curve. And then the bottom one, we kind of can't do, right? We don't have the A value would be somewhere down here. We're just not going to be able to add it on. So I'm going to have to label this. I need to write down my vertices. So I'm going to kind of backtrack and put those down. You should be able to get them too, okay? So make sure you try it. The vertices. My A value is up from the center, so -2, -8 plus 6, so -2. -8 minus 6, -14. Co-vertices. I have to move in the x direction, so it's -2 plus 5, or -5. -2 plus 5 is 3. -2 minus 5 is -8, or -7. So you should be able to get those as well. I know it's 5 o'clock though, so your brain might be falling apart at this point. So just do what you can. Okay. You go from the center along the transverse axis, which is the main axis, the y-axis in this case. So we add to the y values. Keep the center value the same. -8 plus 7.81. -0.19. That's a weird one. Really weird. And then what's next? -2. And I think the next one, if it's -8 minus 7.81, -15.8 or 81. Super weird, but we'll do what we can. Let's see, we need to go negative. That's going to be about this. So hopefully you can see the focus there. So again, like I said, these aren't trivial. These aren't easy questions, but they're also not difficult. They're just long. They take a lot of steps. I would say 5 main steps and a lot more little steps. But if you understand it, they're not difficult. What am I missing? I don't have my final answer for asymptote. So let me get that. My asymptotes. Y plus 8 equals plus or minus 6 over 5, 6 plus 2. So I did that at the beginning, but it's nice sometimes to keep it all in the little space that was provided. Okay, is anyone still alive out there? How you doing? How you feeling? How's everybody feeling? We got 2 more questions to do. Actually, I could do just 1 more question. I'll be okay with it, but I want to do 2. 19 minutes to go. I mean, I could do more. I could make sure we go all the way to 5:20 if you want. I definitely have to do 1 more question. How do we feel? Go on and do the 1 more question and call it a day? So C here, nothing special. Honestly, when you look back at these questions, there's nothing really special about any of them. They're all very similar, so you can say I can say C is for homework. I'm going to do 2A. I was planning on doing 2B and D, but you can just look at the solutions for that if you want, and Mr. Tom's videos have a similar one. I just want to make sure you're aware of this type of question. Man, I really look like white. I'm like a ghost. I don't know what's going on. What's even happening? Hello? Maybe I am a ghost. I don't know. Okay. Clear your mind. Pay close attention. This is a different type of question. You remember when we did ellipses and circles? We had to find the equation. Sometimes they gave us a little bit trickier stuff. That's the same thing here. Write the equation of each hyperbola. So first things first, you need to know what the equation of a hyperbola is, and you need to know what you're looking for before we can solve anything. So These are our two possible cases for hyperbolas. I'll just write, this is what I showed Zara earlier. But it's important that you know what we're looking for, because otherwise, how are you going to solve it? Okay, so this is what we're looking for. We want to make that equation given very little information. And honestly, they're not that difficult. They just require some clever thinking, and I'll try to help you through it. So once again, really all you need this h, and you need k. You're going to need a squared. You're also going to need, I don't know what else to use, b squared. Yeah, it might end up with too much color, but we'll see. And same thing over here. We need b squared for this one. We need h for this, depending on the form. We need negative k, and we need a squared. That's the wrong color. Sorry, I'm getting lost in my colors. Okay. The reason you need those, basically you need anything that's not x and y. X and y are always our general variables. They stay x and y. The problem is we definitely need those 3 pieces of information or 4 pieces of information. And it's thankfully not hard to get, because really all we need to think about, we need to figure out where the center is. That'll give us 2 and 1. And then the second thing we need to do is we need to know that A is the distance from center to vertex. That's always important information. We should always also know that B is the distance from the center to the co-vertices, or co-vertex. For C is the distance from the center to the foci. Okay, didn't need to write all that again. So if I need that information, it's there. But let me walk you through this. Okay, what are we given? Read the question carefully and make sure you know exactly what you've been given. So in this case, we've been given vertices at 2 coordinates. Right away, if I don't graph this, if I don't make a sketch, I'm not going to get anywhere with this. So let's make a sketch. 8 and 14. 1, 2, 3, 4, 5, 6, 7, 8, and 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's a vertex. Remember, that's vertices are on the transverse axis, which means the main axis. We have 2 vertices. Where's the other one? 8 and negative 10. Okay, negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wow, okay. Believe it or not, we know which is the transverse axis now. Which one is it? If my vertices are like this, up and down like this, if my vertices are on the transverse axis, they're on the main axis, I must have a shape that looks like this. I don't know why that went wrong. My shape must be like this, which means I'm going to have a y first in my equation. But if you didn't see that yet, let's work towards it. Where is my center? Anyone have any ideas how I'm going to get my center? What do I know about my vertices? You know, I add A normally from the center and I subtract. Divide the 2 points. Not exactly. I mean, you've got the 2 points. I think maybe you mean like halfway in between. I'm assuming that's what you mean, because that's, yeah. So it's going to be somewhere in between, but if you count that wrong, you're going to get it wrong. So let's just get the y version of the center. And the trick is you just get the average, okay? Add the 2 values, and by the 2 values, I mean take 14 and negative 10, add them up and divide by 2, okay? So 14 plus negative 10 divided by 2. Let me make that more clear. 14 plus negative 10 that would be 14 minus 10, which is 4. I probably didn't need a calculator for that. And that's 2. So what that means is that the center is, what's the center? Well, I know the y value, and the x value I can see from the vertex because it's right here. The center is going to be at 8, 2. So you can see that you have to think in a different way to solve these questions. You have no choice. You have to know what the pieces mean. Okay? So I know where my vertices are. That means that halfway, or the average between them, is where my center is. And now I can get A, because A is the distance from the center to the vertex. So this distance here is A. And what's that distance? Can you figure it out? What's the distance? What's the distance between 2 and 14? What's the distance between 2 and 14? 12. Exactly. So my A is 12. So my first thing that I did was get the center. My second thing is I know that A is 12, but I needed A squared. So I'm going to square it. It's 144. So I found that piece. And I found H and K, whether you believe it or not. That was my K, and H was right here. I'm just color coding so you can see what I'm doing. I hope it's not too distracting. What am I missing? I have H, K, and A squared. I need B squared. Anyone have any clever ideas how I'm going to get B squared? Anybody? Or your brain's mush? Okay. So there's a piece of information we haven't used yet. And it's okay if you don't have a clue. That's why we're doing this here, so you can get a chance to think it through with me. We haven't used this piece of information. The conjugate axis is 2 units long. What that means is that, well, first of all, we have a transverse axis. We've already talked about that. The conjugate axis is the other way. And if it's 6 units long, so 6, that means, let me draw you a quick sketch. If this is our center, that means that we go 3 left and 3 right. That whole distance is 6. That means that B, it's 3 and 3 on either side. So B equals 3. Or in other words, maybe you want a quicker way or a more foolproof way to do this. If it tells you, okay, listen. If it tells you the length of the conjugate axis, you just take 2 times the letter that relates to that axis. In that case, it's B. That's what it is. So in this case, B is 3. Or you can think of it, if it's got to be 6 in total, then take half of it, that's 3. If it was giving you the transverse axis, which you'll notice it does do that sometimes. Let me see if I can find one like it. Yeah, we would do the same thing. Take 8, divide it by 2, and then match it to the same thing. Hamza, yeah, it is basically a radius. If it was a circle, like I try not to use the word radius because radius is actually only for circles, but think of it whatever way you want. If it's 6 across, that's like diameter, halfway is the radius. So whatever way makes sense to you, you do that, okay? So finally, let me just get to the point. I have all the pieces of information that I need. I'll use this really ugly orange. I know that B squared is 9. I just transformed it into green. I didn't know that was a thing. Is it green on yours too? Cool. All right, final step. Let me move this over because I'm running out of space. Final step, actually write the formula. Y minus K. What's K? K is 2. Y minus 2 over A squared. A squared is 144 minus, oh, I square this. X minus H. X minus 8 square that over b squared equals 1. That's my answer. Tiny little bit of work, a crazy amount of thinking. I'm not going to pretend that this doesn't take effort, but I'm also not going to pretend that these aren't asked on tests. I looked at 6 different versions of tests today from previous years, and most of them had a version of these longer answer questions. Like at some point when you do the long answer question on the test, it's either going to be about ellipses, hyperbolas, things like that. There will be one type. I mean, that's what I would expect. I can't tell you because the test doesn't exist yet. But I can tell you that the previous tests I've seen, these questions do come up. And it is confusing, I believe. I completely agree. So what we'll probably do, okay, first of all, I'm going to stop the recording because we're done for the day. So thank you, everybody. See you next time.